Welcome back to ArmanisMath. Today we're going to review for the Chapter 5 quiz. The first one I'm going to start with is example on how to reduce and simplify radicals. And this one is going to be 3x to the 1/2 power times 4x to the 2/3. Okay, we're asked to simplify this one. So how do I simplify this? Well, apparently I have to look at some exponents here, right? This rational exponents. I could basically multiply the constants or the numbers, and then after that I have to deal with the variables. So let's do that. If I take a look at the numbers, that's going to be 3 times 4 times x to the 1/2 times x to the 2/3. So how do I simplify that? I know 3 times 4, that's probably an easy thing for me to do. But what about the other one? How do I do the other one? Well, 3 times 4 is 12, right? What about 12 to the half? I'm sorry, x to the half times x to the 2/3. Well, in this case, you have to find a common denominator, because if you have x to the 1/2 and then basically times x to the 2/3, you have the same base. That means you have to add the exponents. Basically, I'm going to say x to the 1/2 plus 2/3. I do this because I have the same base. Now I have a dilemma. I don't have a same denominator, so I have to come up with the least common denominator, which in this case is going to be what? Can somebody help me? What would be the common denominator between the 1/2 and the 2/3? 6 is. It's very true. Thank you, Myra. So I'm going to make this guy down here 6 by multiplying it by 2. If I do that to the denominator, I have to do it to the numerator as well. So multiply that by 2. This guy here has to be multiplied by 3 in this case, right? 3. Obviously, 3 to the top and 3 also to the bottom. So 3 times here, 3 also times that too. Now they're probably going to be, they are friends now and they can talk because they have the same denominator. Got 3 over 6 plus 4 over 6, which is going to make it interesting. X to the 7 over 6. Okay. Now I'm going to go back here and put that as my answer, except there is something. I mean, they wanted me to simplify, so simplify. Basically, I really have to further simplify the 7 over 6. And I simplify the 7 over 6 by just thinking to myself here, 7 over 6, okay, I know 7 over 6 is like, there's 6 sixes, and then there's another 1 6 on top of it. Here's what I mean. This x to the 7 over, this is 7 by the way, this is 7, is basically an x to the 7th power under the 6th root. What does that mean? Well, this means, remember, the denominator is the root. This denominator is the root. So 6th root, that's why I have the index here is 6. So now if I have this setup, how do I simplify that? Well, what you were saying here, you're looking for something that is multiplied by itself 6 times. The same thing by itself 6 times. So that would be, in my case, it would be the x to the 6 times another x to the 1st. And again, this is the 6th root of that. Well, let's keep going here. The 12 did not change, by the way. The 12 is going to just remain Just gonna drop the way it is. So now again 12. This one I could break down. I could break this one down further. So it's gonna be x to the 6, but I do have the 6 root here, times x to the first, or you could just put x by itself, and then you have a 6 here. Okay. So again, if you looked at this closely here, let me actually focus on this a little bit. I'm gonna use this tool here to focus. Let's take a look at this tool here. See, look at this guy here. You're saying you have an item that is multiplied by itself 6 times, because remember this is the 6th root. So what is this item? What are you looking for that is multiplied by itself 6 times? Well, it's very obvious here. It's going to be the x itself. So that's why you simplify this whole spiel here under this as just 1x, because you have 6 times x's and you have the 6th root. And what's going to be left here on this side is the, can't really simplify that further. That has to be just left the way it is, 6, and the 12 is just the 12. So this is the most simplistic approach to this problem. That's how you simplify it like that. Okay? So I feel that we need to practice this concept here. Do you guys agree? If you need more of this review, let me know. We could get a couple more examples here. Give me something in the chat, or the live stream comment, or a private chat. I need to hear from all of you here. There's plenty of us here to respond. If you need help with this, if you need another example, let me know right now. Okay, looks like we have a unanimous. A lot of you wanted that, so let's do that. Let's just review this concept here. So I'm going to start with this. I'm going to actually break it down into 3 different examples that we could work with just to address this concept here. So what if I have, let's say a to the 2/3 times a to the 4/3. Okay, what would you do here? Somebody help me out. What do you think I could do to the exponents if I have the same base? That is true. Just add the bases. 2/3 plus 4/3. Likely, I have the same denominator. So I have a to the 6/3, right? 6/3. And 6/3 is 2. So that was kind of an easy one. Really can't do anything about that. That's very simple. Here's another one that has a little bit twist to it. And that one is going to be, let's say I have a b to the 1/2 times 3b to the 1/2. So 2 times 3. Then I'm going to say b to the 1/2. But before I do 2 times 3, I really have to be aware, because I just made a boo-boo right now. What's that boo-boo? It was me not counting the second power, this here. Remember, this guy here, this 2 belongs to everybody in this family, including the 3, including the b, and also the c. This 2 belongs to everyone in this family. So if you guys remember PEMDAS, parentheses, we need to deal with that first. So let's deal with that first. So I'm going to drop the 2b to the half, not doing anything about that, and then distribute this power here. So that was the 3 to the second. b 1/2, and I'm going to change the color here, times 2. Looks like I need more room here. And the c has a 1/3 times the 2. And I close my parentheses. Okay. 2b to the half, I can't do anything about it right now. And 3 squared, how much is that? How much is 3 squared? You're going to have to participate, you guys with me, okay? Help me out. What is 3 squared? Here we go, 9. So I've got 9. b to the half times 2. Haha, we've done something similar to that before. Half times 2, how much would that be? Exactly, it's going to be 1. There's 2 over 1 here, and a half. You just basically cancel each other out. So that's going to be to the first. You could put 1, or you could put nothing. And then c to the 2/3. 2/3. Okay, now I'm going to start to multiply out the numbers and then the variables. 2 times 9 is 2. Let me just spell it out here. 2 times 9. And then b 1/2 times b to the first times c to the 2/3. 2 times 9 is how much? What is 2 times 9? 18. How about b to the half times b to the first power? How much is that? I don't know. Okay, well, what are you trying to do? What are you trying to add? We're trying to add what here? 1/2 plus what? Plus the 1. We have the same base, so we just add the exponents. So 1 plus a half, you know, I mean, you could know this mentally, it's 1.5, right? But let's do it as a fraction again. I could need to make this guy a 2, so basically I'm going to have to multiply it by a 2 and divide it by 2. So I have 18. b to the what? 1/2 plus 2 over 2. That's going to give me 3 over 2. And then the c is 2 over 3. Okay, I'm not done yet. I just need, again, to simplify and make it nicer, I guess. This b here to the 3 over 2, this is the same as, can somebody tell me? What's going to be the index here? What's going to be that little number that I put here? Exactly, it's the second power. So it's going to be the second power. Since it's, again, it's the denominator, that's what you do. You put that as your index. I've got b to the third. Basically, there's 3 b's down here. I'll do the same thing for this dude here, which probably going to help, or maybe it's not going to help. Well, but that's, well, I'm just going to try to do this thing, which is the cubic root of c squared. That's not going to help really, but I just wanted to try it. 18 is going to stay the way it is. That didn't change. Again, 18 drops the way it is. Now, how about this one here? Remember when we said we need to practice? So I've got 3 of them, and I only needed the second root. So I only need 2 identical items to separate them. So in here, you got actually basically you have b squared times another b to the first, right? And both of them are to the second power. To second power, I should say second root. And well, let's keep going with that c for a second. Here's 18. If you have two of the same, well, that's exactly what you're looking for the square root. So that means just a b. This guy's going to remain under the square root. That's not going to be helpful to me. It's just going to stay under the square root as b by itself, or b to the first power. While the c here, I mean, I wanted to find a way, but I have to have at least 3 c's, and I don't have that. The most I have here is just 2 c's, which means I just have to leave it the way it is. I can't do anything about that. I'm sorry, I tried. To the third power here, third root. Okay, a little bit lengthy. Obviously, there were some shortcuts. I did not take the shortcuts. I wanted you to see everything in details for you to observe and understand the actual concept that is presented here. So I've got 18b square root. By the way, this is optional. You don't have to put 2 because square root is common, but that's okay if you're going to put it. And then times the cubic root of c squared. Okay, I'm going to go over this pretty quickly again. So let's see what's going to happen. So I was given a problem that looks like this. 2b to the half times this amount. This was raised to the second power. I made a boo-boo by not distributing this 2 at the beginning. And right off the bat, I caught myself and I said, no. This has to be multiplied first. This has to be distributed first, which we did. And we distributed that 2. And then we found out that we have basically numbers that could multiply, but the b's have rational fractions in them. Fractions that have exponents that have rational exponents, I should say. Which basically looking for some roots here. So I have to have a common denominator for the b, which I did. This is also missing a c sound here. So we could put that c. That didn't disappear. C to the 2/3. So I kind of isolated myself talking about the b's first. And then I did the simplification for the b. Further dissect the 3/2 into the square root and the third power. And I took care of the 3 b's into 2 b's and 1 b. The square root of b squared is just a b. And the square root of b is just square root of b. And then that left me with the cubic root of c squared. Okay. I know it's a little bit lengthy, but it was necessarily to go through this in details. Let's do a quick one, since I promised we're going to have 3 of them. So let's do another one here. And this one's going to be, let's do it here. Let's say I have x to the 5/3. Give myself room here. 5/3 times x to the 3/2. Now it's your chance to help me out. What do you think I should do here? What do you think is my first move here? I am waiting for some of you to tell me what you guys just think. Because multiple users are typing. I love it when I see that. Find the least common denominator. So obviously in this case, what do you think is going to be the least common denominator here? What do you think is going to be the least common denominator? That's 2 is too small. Unless if you're saying to multiply this by 2. Yeah, exactly. 6 is the one that I'm looking for. So to get to 6, I have to multiply by 2. To get to 6, I've got to multiply by 3. And if that is true, then I'm going to have x to the 10 over 6 divided by times x 9 over 6. Okay, to do this correctly, I've got 19 over 6. That's a big number. It's okay. So 19 over 6, in my brain, I'm looking for 6's here, right? 6's. So I will have the 6th root of x to the 19th. That's a big number. Okay, no problem. Now we have to simplify this further, right? So x to the 19th, I would highly, recommend that we split them in groups of 6's. So you could say this is x to the because of the 6 here. So you find a number that's divisible by 6, by the way. What would that be? What would this be here? So I'm going to put x to the 6 times x to the another 6 times, wow, that's going to be times x another 6, right? And then times another x to the what? X to the 3rd, right? No, it's not 3rd, it's x to the 1st. Because 6 times 3 is going to be how much? What's 6 times 3? What is 6 times 3, you guys? 18. Exactly. So for every 6, I'm going to pull out one of them outside the radical. That's going to be x. For every 6, I pull out one of them. Every 6, I pull one out. And the one that I'm going to be left with is 1x that is under the 6th root. And x times x times x is going to be x cubed times x under the 6th root, or the 6th root of x. And that should be it. Okay.